Hello, welcome to All This Math. This is Professor Parker, and we're about to do some more geometry like we did earlier today. And this is another word problem. So the first thing we have to remember is, number one, just not to get intimidated by word problems. We want to attack the word problem. We don't want to let the anxiety take over, and we want to first read it and try to understand what it's actually saying. Understand what information we're given, and then understand what question we're being asked. And then we also want to understand what information we're given and how we can use that information to figure out what we don't know, and then eventually answer the question. So first, if we read the question or read the word problem, it says that you want to give your friend a soccer ball for a gift. All right, so just imagine. And I also advocate for students to actually inject themselves into the actual word problem. So imagine this is you. Imagine you actually do want to do this. Imagine they got a birthday coming up, or it's a holiday, or whatever, a graduation coming up, and you want to give them a gift. And they play soccer, all right? Like my nephew Nasir, he plays soccer. So imagine you were giving him a soccer ball for his 8th grade graduation, all right? Imagine you were doing it for a gift. The soccer ball has a volume of 85.3 cubic inches. So that right there, that's important information. It usually is. So I'm going to underline the word volume, and I'm going to underline 85.3 inches. And actually what you should do is, on your paper, you should actually write that down. So write something like V equals 85.3 pi. It's not just 85.3, it's 85.3 pi, which means 85.3 times 3.14 cubic inches. So that's important information. The question is, what is the volume of the smallest cube-shaped box that the ball will fit inside? So you don't want to have a big, huge box with a whole bunch of space inside, so the soccer ball is like rolling around and moving around. And let's say you live far away and you want to actually mail this gift to my nephew Nasir, and you don't want to have this huge box that you got to pay extra for shipping and handling at the post office for, or extra at UPS, or extra at FedEx, or wherever you're getting the ship from. So you want to pick the box that is not too small, so that way the soccer ball can still fit inside the box. But you also don't want to pick a box that's too big, and then you got the box like rolling around inside of it. And plus, you paid extra money that you ain't had to pay if you'd have got a box that was more appropriate, that actually fit the size of the soccer ball. So we're going to use math and some formulas to figure out what size of box we should get. All right, so dig this. What is the volume of the smallest cube-shaped box? So think about this. There's a formula for that, right? Just like we have apps for everything, we have formulas for almost everything. There's a formula to find the volume of a cube, right, Nassim? Exactly. So the volume, now this right here is the volume of a sphere. I'm going to put SP for sphere, right? Because that's what a ball is. A three-dimensional object, it's round, it's a sphere, okay? Now, the volume of a cube is just the length of one of the sides to the third power. Because in a cube, the length, the width, and the height are all equivalent. That's what makes it a cube, like a Rubik's Cube, right? The length, the width, and the height are all the same. And this says cube-shaped, all right? Now, if it was just any other type of rectangular prism, then we would say you would use the formula length times width times height to find the volume. But because the length and the width and the height in this particular rectangular prism, which is a cube, are all the same, then basically you could just say length to the third power, or width to the third power, or the height to the third power, because they're all the same dimension anyway. So typically when we talk about a cube, we use the letter S to represent the length of one of the sides, and we just raise that to the third power. So we want to know how this can fit inside of here. All right. So this is a sphere, right? And this is actually not the formula. I shouldn't have wrote that there. This is not the formula for the volume of a sphere. This is the volume of the sphere. But I will write the formula for the volume of the sphere too. So the volume of the sphere is, and in case you don't have it memorized, that's fine. But eventually you should memorize these formulas. But in the meantime, write them down. You can find them on the internet, or you may have a reference sheet already. So yeah, 4/3 pi r to the third. That's your formula that you need. You need the volume of a sphere is equal to the fraction 4/3 times pi, which is actually a number represented by a letter. That's 3.14. And then r, that's the radius. Now, think about it. The radius, you got, this is the sphere. And it's 3D, right? Now, a sphere is like a 3D circle, right? That's all a sphere is. So the radius is what? The radius is the length from the center of any circle to the edge of the circle. It's not the length all the way across the circle. It's the length from the center of the circle to the edge of the circle. So think about that and think about the other question that I asked. So actually the other thing that I said earlier on. In these word problems, really in any word problem, for real, you have to take what you are given. You take what you know and use it to figure out what you don't know. So one thing we know is we know the volume of this soccer ball, right? And we also know, and from that, we can figure out what the radius of the soccer ball is, right? So, but what we don't know is the volume of the box. We know the volume of the soccer ball. We don't know the volume of the box. So what we need to do is figure out what the volume of the box has to be, because again, these are two different shapes. This is circular, the box is square, right? Because it's a cube. So the soccer ball has to fit inside of the box, and it's going to be some space left over because they're not the same shape. Just like if you ever bought anything before that was circular and you took it out the box, you recognize from looking in the box that there was extra space around. All right? So what we need to do is figure out what the size of this box would be. Now we got to use some critical thinking. If I'm going to put this soccer ball inside of the box, right? And just imagine, like I said, just imagine you ever took something that was circular in 3D out of a box, right? Think to yourself, think back, how wide was that thing? That thing was probably took up the whole space in the box, right? So it probably, the length or the width of the box was probably just as long as that ball was or that circular object was. So basically what that means is that the length across the box was probably the same length as would be from here all the way to here. From here all the way to here would probably be the length of the box in order for something circular like this, like a soccer ball, to fit inside of it. Because think about it. What if I drew like a box right here? In order for this soccer ball, I know this drawing is not perfect, but just work with me, right? So in order for this soccer ball to fit inside of this box, don't you think that the width of this soccer ball would have to be equal to the width of this box? Right, not saying? Mm-hmm. Yeah, exactly. So we got to first think about the concept. Once you understand that concept, then we can use the math and figure out the numbers. But before we even get to the numbers, you should think about the concept. So now we understand the concept. What we're trying to do is figure out what the volume of the box is. But before we can figure out what the volume of the box is, we need to know what one of the lengths of the sides of the box is. So we need to know what S is. Because right now we don't know what S is. But we need to think about, well, what does S have to be? S has to be just as wide as the soccer ball is. And now we can figure out how wide the soccer ball is by first figuring out what the radius of the soccer ball is. So it's like a progression. It's like a whole bunch of things you got to do. Everything is interconnected. Once we find the radius of the soccer ball, then we'll know the diameter of the soccer ball. And we also know that the diameter of the soccer ball is just as wide as the width of the box. And then once you know the width of the box, then we just throw that number into this formula right here, and we just take that number and raise it to the third power, and we'll know the answer. But first you got to understand the concept. You got to be able to read the question and read the word problem, read all the information, and then come up with your formulas. First, know what formulas you need to use, right? Since they're talking about volume, they're talking about a soccer ball. Okay, what kind of shape is a soccer ball? It's a sphere. What's the formula for the volume of a sphere? It's this. Then they're talking about a cube-shaped box. So they're talking about a cube. And they're talking about the volume of it. So what's the volume of a cube? This formula right here. V cube, V of a cube, equals S to the third power. Just like the volume of a sphere is 4/3 power R to the third. So now we solve for R. And this is how we solve for R. we take 85.3, right? 85.3 pi. Replace that with v. Or replace v with that, because that is that. So we got 85.3 pi is equal to 4/3 pi r to the third. All right. Now my whole goal is to solve for r. I want to know what r is, because once I know what r is, then I can figure out what the diameter is by just doubling r. And once I know the diameter, then I know how wide this box needs to be. And once I know how wide this box needs to be, like I said, I can then figure out what the volume of the box has to be from using that formula. Because the width of this box is s. So then I could just use that formula and do s to the third power. Right? All right. So now I do, let me think. I want to solve for r. So the first thing I'm going to do is I'm going to get rid of pi. So that means on the right side, I'm going to divide by pi. Now, why did I divide by pi instead of multiplying by pi or adding pi or subtracting pi? Because pi is involved in multiplication right here. Because this says 4/3 times pi times r to the third. Pi is being multiplied. So if you ever want to eliminate something in any equation, no matter what the equation look like, you always do the opposite operation. So you first got to look at the equation and say, okay, what is it doing right now? All right. Then you base your next move on that. You say, okay, well, if it's being multiplied right now, I'm going to need to do the opposite of multiplication, which is division. That's how you get rid of it. So this is going to happen. That's going to turn into a 1. So now you're just left with, on the right side, 4/3 r to the third. But also in an equation, if I do something on the right side, I also got to do the same thing on the left side. So then I do pi divided by pi, and that turns into 1s. All right, so now on the left side, my next step looks like this. 85.3 is equal to 4/3 r to the third. All right, and again, I'm trying to solve for r. So I got to get rid of 4/3. So, now see, how do I get rid of 4/3?
Multiply on both sides by 3/4.
Why do I multiply by 3/4?
So that it cancels out and equals to 1.
Right, and 3/4 is what? Starts with an R. Come on, bro, don't embarrass me on live. Damn. Starts with an R. I taught you better than that. The reciprocal, bro. It's called the reciprocal.
Oh, yeah.
COVID-19, man. It's messing with your brain, bro. It's messing with your brain. All right. So look, you got to get rid of 4/3. So multiplying by the reciprocal is the same thing as doing division when you're dealing with fractions. This 4/3 is being multiplied. So you might be wondering, well, why is he multiplying? He just said you got to do the opposite operation. Since the pi was being multiplied, to get rid of it, you got to divide. Now this 4/3 is being multiplied. Now how you trying to change the rules on me? He just says you got to multiply. Well, technically I did say that, but understand that with fractions, when you divide a fraction, dividing a fraction is the same thing as multiplying by its reciprocal. So dividing and multiplying by the reciprocal are the same thing. So I can do times 3/4 on the right and times 3/4 on the left. The 3's cancel out, the 4's cancel out, and then we got r to the third, and then 3/4 times 85.3. I say, do me a favor. I need you to calculate this. I don't have my calculator on. I'm not doing that in my head.
My calculator upstairs.
Go get my calculator over the table over there, man. And don't do the bruh man slow bot. Don't do the bruh man slow bot. I need you to like hustle up. All right. Now I mean, people are watching this, man. They want to get to the end of the problem. All right. So 3/4. So flip that to 0.75. Do 0.75 times 85.3.
63.975.
63.975. All right, 63.975. So I know what they're trying to do here. What's going to happen is now I want to solve for r. So now I need to get rid of that exponent 3. So I need to do the opposite of cubing something, or the opposite of raising something to the third power. So that would be taking the third root of something, right? So I'm going to just round this up to 64. That's what I'm going to do. I'm going to change this to 64, and I'm going to rewrite the r to the third. And to get rid of that, I got to do the opposite, which is take the cube root of both sides. So now that's a 4, because 4 times 4 times 4 is 64, right? And that's going to be r, because this root right here, or the index in the radical sign, and this exponent right here, they cancel each other out, right? So that leaves you with r. So now I know that 4 is equal to R. But that's not the final answer. That's just information I got to use to get to the final answer. I know that the radius of this soccer ball from the center to the edge is 4. But I need to know how long is it from the edge to the other edge through the center, right? So that means that all the way across has got to be 8. Because if from the center to the edge is 4, from the center to the edge, and then from the center to the edge again, that's 4 plus 4. So that gives us 8. So that's 8. So that means that this box should be 8 across, right? So now that means that since S is 8, then the volume of the cube is this formula right here. So we got V is equal to 8 to the third power. So V is equal to 8 times 8 is 64. And 64 times 8 is 512. But it's not just 512. It has units. It should be 512 cubic inches. Now, if you think that's weird, you might be thinking, well, that's only 85.3. And that's 512. Those numbers are very different. Well, what would it be? Think about it. It's not 85.3. It's actually 85.3 pi. So it's really 85.3 times 3.14. Bro, do me a favor. Do 85.3. You know I was about to ask you that, didn't you? Do 85.3 times 3.14. And what is that?
$267.8.
267.8. So this is like 267.8 inches cubed. It's still kind of far off, but dig it though. Think about all that space, right? Because this is circular, right? This is circular. It's going to be all that space in here and in here, and it's all the way around. So it is going to be a lot of like just air in it. It's going to be a lot of dead space that's not going to be used. But the smallest cube you can come up with in order to fit this soccer ball in it would have to be 512 cubic inches or 512 inches cubed, right? Now, if the length of this cube was less than 8, the soccer ball wouldn't fit. It's got to be at least 8 inches wide because the soccer ball is at least 8 inches wide. All right? So, this problem was for Nasir. I hope he was taking notes. I hope he was paying attention. Hope he wasn't getting distracted by Maceo. All right? My other nephew. Nasir and Maceo are my nephews. 2 of them. I have several. But at any rate, I hope you understood this. If you still need further help, further assistance, hit my phone. All right? And thank you for the rest of you. Thank you for tuning in to All This Math. If you have questions that you need reviewed, please do not hesitate to send pictures of those questions to the All This Math inbox. And depending upon the demand, your problem might make it to this board. Thanks for tuning in. Peace.